All right, so let's do some integration requiring some u-Substitution. So this is section 5.5. And you've got the problems on the study guide that you can work. And then I just pulled examples off the integration test. So with 5.5, the first objective said to find the indefinite integral using the general power rule. So you could have various situations given to you. You might have a radical, you might have a fraction, like maybe I'll do 11 also. 11, I'll do 11 as well later. Okay, I'll just put it in there. Put it right here. Well, let's go ahead and finish this one, then I'll do 11. So what they're talking about is when you have a problem like this, you can let u equal that inside part. And the derivative of that would be 6x to the fifth dx. I see the x to the fifth dx there, so I can adjust by getting that 6 off of that side. Okay, and so I could rewrite this as the square root of u, the 1/6 du. And by now we've done this a lot, so you might already be writing that 1/6 out in front. So that's what I've really got it. Oops, I wish I had written that already as a fractional exponent. So let me do that. So I really have 1/6, and then I have u to the 1/2 du. So I can use the general power rule. I can add 1, which would get me 3/2, get rid of that by dividing by 3/2, which is the same as multiplying by 2/3. Just imagine that exponent coming down and you needing to get it to cancel out. You would have to have a 2/3 there. Don't forget about the 1/6 that was already there. And don't forget about the plus c. Okay. Then you simplify. So 2 would go into 6 3 times. I'd actually have 1/9. U was actually equal to x to the 6th plus 8. So you got to put that back in, and that's to the 3/2 power. Okay. So I would get the 1/9 x to the 6 plus 8 all raised to the 3/2 power. Okay. Now let me go ahead and do number 11, which is another example of evaluating or finding the indefinite integral using the general power rule. Okay. I want that to move. Okay, that's not going to move down. All right, let me see if I can do it just right over here. So here's number 11. Okay, 11 was this one. 12x dx, and then down here we had 6x squared plus 3 all raised to the 4th power. Okay, and the dx, they just wrote it up on top there. So like on the other one, you let u be that inside part, and then du wound up being 12x dx, which turned out to be pretty convenient because there's 12x dx right there. So we're going to rewrite this as 1 over u to the 4th, and then that 12x dx is our du, and the u to the 4th in the denominator is like having 1 over u to the 4th is the same as u to the negative 4th. Haven't integrated yet, so I'm keeping that integration sign on there. Now I'll integrate by adding 1, getting rid of that new exponent, and then a plus c. So that's basically it. All I got to do is put the 6x squared plus 3 back in and write it, since it had a negative exponent, I'm going to put that back in the denominator with the 3 that came from 1/3, and then keep that plus c. Okay. All right, so something like that is what they're talking about when they say find the indefinite integral using the general power rule. All right, then they have one, find the indefinite integral of a trig function. Okay. Oh, before I did that, I thought I would do another integration problem, but this was a definite integral involving u-Substitution, but it did require the general power rule. So let me do 20 from the integration test, and then we'll do the trig function and the exponential one. So here's another chance to practice that general power rule. So u would be x squared plus 1. So the derivative of that would be 2x dx. Okay? So x dx would be 1/2 du. And here's the x dx. So this would be u to the third, and then that's 1/2 du times 1/2 du. I'm not putting the bounds on that right now because they're not, these go with x's. The 0 and the 1 are x's. Okay, so I'm just doing the u to get the integration in there. So this would be 1/2 the integral of u to the third du. So we can do that. That would be u to the fourth divided by 4, or multiplied by 1/4. We already had a 1/2. We need the plus c. So we wind up having the 1/8, the u to the fourth plus c. Now, that then needs to be can be evaluated. Now, what I could do is find u of 0, which would be 0 squared plus 1. Find u of 1, which would be 1 squared plus 1, which is 2. And then not switch back to x's, but just evaluate this. And we don't really need the plus c because we're going to subtract that off. So evaluate this from 1 to 2. So those are equivalent to having x's from 0 to 1. And then never go back to the x's and just do 1/8 of 2 to the fourth minus 1/8 of 1 to the fourth. And we would wind up getting 16/8 minus 1/8, which equals the 15/8 on that. Okay. And then if that change of variables confuses you, then what you want to do is when you get to here and you have the 1/8 u to the fourth, you can put back in the x squared plus 1 to the fourth, and then evaluate that using the original 0 to 1. And you would get 1/8, 1 squared plus 1 to the fourth, minus 1/8, 0 squared plus 1 to the fourth. You'll get the same thing, of course. This right here would have been 2 to the fourth, giving you the 16/8. This right here is 1 to the fourth, giving you the 1/8, and you'd get the same thing. So it's just a matter of what really makes sense. Whatever you do, you want to understand it, not memorize it. Okay? All right, so I went ahead and did that. On here, it didn't talk about evaluating a definite integral using the general power rule, but it just gave us a chance to practice that general power rule. Okay? All right, so then it talked about doing a indefinite integral of a trig function. So they're talking about something like this. Not one that requires the logarithm rule, so just an ordinary type. So it might be sine, it might be cosine, it might be a secant tangent, or it might be a secant squared, something like that. Okay? All right, so we got one here to do. And I would let u equal 9x minus 10. So du would be 9 dx. Okay. So this dx can be replaced with the 1/9 du. And here I just have sine of u. So I'm going to bring the 1/9 out. And then I just have to do that basic integration now. And I know sine came from cosine, but you got to be careful. Sine came from cosine, and you need to adjust that or think about how, either the rule, either you've memorized this rule, okay? Either you've memorized that, or you just need to think about, sine would have come from doing the derivative of cosine, but when I do the derivative of cosine, I would have gotten a negative. So I need to adjust for that and put a negative on this. And then I still have that 1/9, and I have a plus c. So that's negative 1/9 cosine of u du plus c. Okay. And we put the original 9x minus 10 back in, but we're not doing a definite integral. So we're not evaluating. So that would be your final answer. So that's the type of thing they're talking about for the indefinite integral of a trig function. Now we need the indefinite integral of an exponential function. So the example on the test was one like this. This was question 13 on one version. And so it's one that involves e to a power. But the power isn't just x, it's 5x. So we'll let u be 5x. So du would be 5. Okay. Now this one, if you're developing some understanding of this, you can be a little less formal. Okay, so you could have put in place of the dx a 1/5 du. Okay, you already had this 10 over here. Oops. So now we got everything in terms of u. So see, the 10 could come out, the 1/5 could come out, and we're really just integrating e to the u du, which would be e to the u. Okay, so here that would be 2 e to the u plus c, and e to the u is really e to the 5x. So we'd have 2 e to the 5x plus c. Now actually, this is one where you really probably could do this without so much. You know e to the 5x came from e to the 5x, and then when you do the derivative of 5x, you get a 5. And so you know you need a 2 to make the 10 happen. So if you've gotten the hang of it, you probably could see that without going through a whole lot of extra steps. All right, so that is the section 5.5 objectives they were talking about, and then go ahead and work the ones that you see on that study guide as well. Make sure you're comfortable with those.